Imagine you're baking a cake, but instead of grams, your recipe uses a unit called moles. Confusing, right? But what if I told you this is a common concept in chemistry? Atomic and molecular masses are a bit like the weights of different ingredients. Just as flour and sugar have different weights, different atoms and molecules have different masses. These masses are usually so tiny that we use a special unit to measure them, called the atomic mass unit. But how do we relate these minuscule masses to the larger amounts of substances we deal with in everyday life? Enter the mole. The mole is a unit in chemistry that bridges the gap between the atomic and the macroscopic world. It's like a translator, helping us understand how many atoms or molecules are in a given amount of a substance. So the mole is like a bridge, connecting the microscopic world of atoms and molecules to the macroscopic world we live in. Now that we've got a grasp on atomic and molecular masses, it's time to dive into the mole concept and molar mass. Picture this: you're a scientist, and you've just discovered a new element. You're thrilled, but you've got a problem. How do you measure something so small, so infinitesimal, that it's impossible to see or touch? Enter the mole concept. The mole is simply a unit of measurement in chemistry. It's used to express amounts of a chemical substance. Think of it like a dozen eggs. A dozen signifies 12 of something. Similarly, a mole signifies approximately 6.022 times 10 to the 23rd power of something. This something could be atoms, molecules, electrons, or anything else. Now, what about molar mass? Molar mass is the mass of 1 mole of a substance. It is measured in grams and is numerically equal to the element's atomic weight. For example, the molar mass of carbon, with an atomic weight of 12.11, is 12.11 grams. You might be wondering, why is this important? Well, these concepts form the basis of stoichiometry, which is the calculation of quantities in chemical reactions. It's like the recipe for a chemical reaction. Just as you need to know how many eggs to use in a cake, you need to know how many moles of a substance to use in a reaction. Furthermore, these concepts have real-life applications. For instance, pharmacists use the mole concept when determining the correct dosage of medication. Environmental scientists use it to calculate pollution levels. Even bakers use molar mass when they measure ingredients for a recipe. So, as you can see, the mole concept and molar mass are not just abstract concepts. They are fundamental tools in the world of chemistry and beyond. Remember, understanding the mole concept and molar mass is like having a secret decoder ring for the language of chemistry. So we've covered atomic and molecular masses and the mole concept. But how do these tie into percentage composition? Well, percentage composition is essentially the proportion of each element's mass in a compound. It's calculated by dividing the total mass of each element by the total mass of the compound, then multiplying by 100. Imagine you're baking a cake. You need to know the exact amount of each ingredient to get the perfect result, right? Similarly, in chemistry, we need to know the percentage composition to determine the chemical formula of a compound. Let's take water, for example. It's made up of hydrogen and oxygen. By calculating the percentage composition, we find that water is roughly 11% hydrogen and 89% oxygen by mass. This allows us to understand and predict how different elements will react together, forming the basis of many chemical calculations. So, percentage composition is like a recipe, telling us the proportion of each element in a compound. We've unraveled some essential concepts in chemistry today, but remember, this is just the tip of the iceberg. We delved into the fascinating world of atomic and molecular masses, opening doors to understanding the weights of atoms and molecules. Then, we sailed through the mole concept and molar mass, key tools in the realm of chemistry that allow us to calculate quantities in the microscopic world. And finally, we touched on percentage composition, an important concept that reveals the proportional amounts of elements in a compound. The beauty of these concepts lies not just in understanding them, but also in applying them. So, delve deeper, explore further, and let these concepts illuminate your studies. Remember, knowledge is a continuous journey, and every bit you learn brightens the path ahead. Thank you for joining us on this chemistry adventure. If you found this video helpful, please give it a thumbs up, share it with your friends, and don't forget to subscribe to Facts Academy 0122 for more enlightening content. We'd also love to hear your thoughts in the comments below.